Hello everyone! Develop green buildings and constantly promote green and low-carbon development. Promote harmony between man and nature. Prefabricated buildings actively respond to the National Green Building Development Strategy. In such an era background, we should keep up with the pace of the times. Please follow me to open the door of prefabricated learning. Today, let's learn 1+X assembly building elements, fabrication, and installation. Subject 1. Post-simulation process of fabrication of exterior shear wall panel. Today's video is taught by the teacher from Langfang Junk, Construction Industrialization Innovation Research Center.
Hello, everybody. In this section, we mainly explain the operation of Elements Production Module. First of all, we make preparations before production. Wear labor protection articles first. Then check the factory hygiene. For example, let's first check the placement of molds. First of all, we shall check for sanitary waste around the line marking machine. We can click on the mold's placement area. Then switch to our storage area and check whether there are rubbish. No rubbish, and then we'll switch to the injection point. See that there are rubbish at the injection place? There is rubbish at a position where the molds are placed. Then look at the reinforcements binding area. Whether there are rubbish in the storage area and processing area of reinforcements binding area. Let's click the mini-map. You can also see just now that if you click on the small map, it can quickly switch to our area. In addition to the Alt key, the mini-map has this function. This is a reinforcements processing area, and you can see the rubbish. It is a wrong click. This is a reinforcements processing zone. This is the storage area for reinforcements. It can be seen that there is no rubbish in the reinforcements storage area. Then we switch to the reinforcements binding area. And we can see that the reinforcements binding area also has no rubbish. Pour the elements. There are no rubbish at the elements pouring track. Cleaning a material distributor. There is no rubbish at the cleaning place. Translation, car. There is no rubbish at the translation vehicle. Elements, pre-treatment. Napping. There are rubbish at the napping place. Finishing. Let's switch to finishing. There are rubbish at the finishing place. Steam curing of elements. There are no rubbish at the steam curing place. Let's take a look at the lifting and warehousing. This is the lifting and warehousing area. There are no rubbish at the mold removal place. This is a washing pool. There is also rubbish at the washing pool. This is a vertical machine. There is rubbish at the vertical machine. Then click OK. Check the equipment. Click the console. First of all, the oil injector rises and falls in the mold placement area. Click down first, and the device cannot run. Check. Fuel injection nozzle switch is faulty. No problem. Is there any defect in the track appearance of the preparation area? Let's click on the mold preparation area to see its appearance. A situation like this is that there is something wrong with the track line. Then we check it. Whether the appearance of the track and the steel binding area is faulty? Let's check them in turn. Then make a choice. Elements pouring area. First of all, Whether the equipment of the concrete transport vehicle is faulty, we switch to the element's casting console. Then, forward, the device cannot run. Whether the valve switch of the distributor is faulty, we check for faults in turn. Is there any fault in the vibration platform, ascending and descending? Click down. No problem. Click up. Then Elemain's pretreatment. Is there any fault in the operation of the knapping and leveling machine? Let's switch to the knapping and leveling machine. Then click the knapping machine to go up and down. The equipment fails to run. It's knapping and leveling, advancing and retreating. Is there any fault in the finishing equipment? There is something wrong with finishing. Is there any fault in the operation of stacker? We can click Move West. No problem. At the panel lifter. First of all, whether there is a fault in the operation of the panel lifter. Let's switch to the panel lifting. Click it. The equipment fails to run. The sweeper is fine. There is no driving problem. Click OK. In this case, we are done with preparations. We choose Plan. We operate the mold placement process. According to the prompt of the current process, we will draw a line first. We click on the operation panel of the scribing machine. Click to enter drawings. Click the drawing. Select the template diagram and click the middle mouse button. Pulley can zoom in and out of drawings. One layer panel. According to the front view, the width of one layer panel is 2680. The height of one layer panel is 2780 from our side view. Internal mold. Because one of our external panels has no internal mold, we enter 0. The second layer, the width and height of the second layer are actually the width and height of the internal panel. It can be seen from the front view that its width is 2100. We can see from the front view or the side view that its height is 2640. Click OK. Next click Draw Line. Click the console die table to advance. Then reset the scribing machine and click Scribe again. At this time, the second layer mold is drawn, that is, a line in the bottle of the internal mold. Then click the Reset die table to move on. When the die table enters the injection area, we need to get the release agent first. Then click on an operation panel of our fuel injector. When the operation panel is in this position, it has a small hand. The mouse becomes a small hand and can be triggered at this time. Click Add Release Agent. Because the fuel injector is a key and important equipment, so we need to control our fuel injector through the console. We click the injector to descend and open the valve. Click Start the die table to advance. At this point, we can take a closer look. The color of our mold table has changed slightly. Then, close the valve. click up. When our operation is finished, one of our above process tips will be checked. Let's begin to get the molds. The mold is in one of our tool libraries. Click the mold. The data of molds get is the same as the data marked by us. Let's take a look at the fixed end of the mold. It is a fixed end of the first layer mold. It is. The length here is actually a width where we draw the line. Then the fixed end, we take the bottom of the mold. That is to say, the bottom end of one of our members as the fixed end. Then the mold at this time, the fixed end of the mold. Its length is 2080. For the thickness, so the thickness of the mold is actually our thickness here. Let's take a look at it from the right side. The first layer of mold includes the external panel and the insulation panel. The thickness of our mold is the thickness of the external panel plus insulation panel. That is 100. There is a curb here. This curb mainly plays a waterproof role. This curb is usually made on our external panel, that is, the first layer of mold. So we should choose L-shaped groove. Then the parameters of the non-fixed end and the fixed end of the mold are the same, which is 2680. Thick. We can see. From the drawing, it can be seen that a non-fixed end mold on the first layer also has a curb. The mold at the left of the fixed end, its length is actually this height is 2780. The thickness is also 100. Then it's just that there are no curb at the both ends. From the bottom view, we can see that there are no curb at both ends. Let's choose none. The right side of the fixed end is also 2788. The thickness is 100. Then we can enter 0 for the internal mold, because there is no internal mold. Then the length of the second layer mold. The second layer mold is actually one of our internal panel. Its length is 2100. For thickness, we can see from the side view that the thickness is 200. Non-fixed end is also 2100. The left side of the fixed end can also be found through the front view or the left view. Its length is 2640, and its thickness is also 200. At this point, we click Get. After coming out of the mold, after the mold appears here, we have to check the mold. We choose Tools. Then check the lateral bending first. When the difference between the two values is measured to be within 2 millimeters, it meets with requirement. We click OK. If it is more than 2 millimeters, we need to click Replace. Let's click OK first, and then do a rust inspection. Rust inspection shows that there are obvious traces of rust in this model. We click Replace. We're going to place molds. We put the first layer of mold. We select the mold in the tool drag area. Click left. Then drag the fixed end and the unfixed end. Then the left side of the fixed end and the right side of the fixed end. The standard of placement is basically no obvious seam. Then click on the first layer. Placement is OK. In this case, our first layer of mold is the preliminary placement. Then, a preliminary fixation is carried out. Select Tools. Perform an initial fixing on the four-sided molds in turn. The side length of a mold is measured. All four sides are measured. Then we found that the side length corresponds to our drawings 1 by 1. Then measure the diagonal line. There is a standard for measuring diagonal lines. The difference between diagonals should be less than or equal to 3 millimeters to meet the requirements. From here, we can see that the side length is much larger than this side length. It's 16 millimeters bigger. So, we have to choose the adjustment tool rubber hammer to adjust. So we have such an idea of adjustment here. This side is longer than this one, so let's shorten the diagonal. Then we will take this fixed end mold as the standard. Move here, move to the left. That is to say, one side length of it. One of its diagonals becomes smaller and this diagonal becomes larger. Then we move to the left and we can hit the mold. We're going to hit one of its outer sides. Every time we hit, our data will be changed. Until our diagonal difference meets the requirements. Of course, the higher the accuracy, the better it is. We can hit the inside of it. In this case, our diagonal difference becomes 0. Then we'll do a final fixation. Select the magnetic box. In this case, we'll make the final fixation of the mold. Then paint the release agent, because it is the external panel. The external panel needs to be painted with mold release agent. Retarder has been selected, so we don't have to choose anymore. We will place the mold of the internal panel, that is, the mold of the second layer. The same operation is carried out to initially fix the mold. Then the measurement of the mold is carried out. Then measure the diagonal line. 3374 and 3372. At this point, you cannot correct the accuracy. You can also correct the accuracy to 0. It's the same principle just now. We need to choose the rubber hammer again. Of course, we still ask everyone to be as precise as possible. Then we're going to paint retarder. Because our internal panel is equivalent to our shear wall, it is necessary to brush retarder for later washing to form rough surface. The retarder applied is to be triggered, and one of our molds is to be triggered. Orders will appear. Then, mold's placement is completed.
That's all for this section. I wish you all a happy learning journey in the course of prefabricated concrete construction.